Right, let's get started, and the rest will join us, I guess, in a few seconds. Welcome, everybody. Hi, welcome to today's meetup. My name is Dalia, and I'm from Elastic's community team. Today, we're here to hear from Sebastien, who is a senior software engineer from Elastic. He's going to talk to us about running the Elastic stack on Kubernetes with ECK. We will take all the questions in the end. And if you ever want to present at one of our awesome meetups, please let us know. We always look for awesome speakers who want to share their stories with us. So if you want to be one of them, get in touch with us. So Sebastien, please go ahead.
Sure. I'm going to share my screen. Hi, everyone. Is it the right screen? Yeah. Like that, maybe. Oh, good. So as Dalia said, my name is Sebastien. I live in Toulouse in the south of France. If you've never been there, you should. It's a nice city. Probably a bit colder than Italy, but still nice. So I'm a software engineer at Elastic. I work in the cloud team, and more specifically, I work on a product called ECK, Elastic Cloud on Kubernetes. That's what we're going to talk about today. If I can go to the next slide, apparently doesn't want to. All right, let's try again. All right, all good. So at Elastic, we have a little bit of history with Kubernetes. You may or may not know, but for the past few years, we've been working very close to Kubernetes and the Kubernetes community. One of the first things we did is really some official Helm charts for the Elastic stack on Kubernetes. They're free on GitHub. We also worked a lot on integrating bits with the Kubernetes ecosystems. For example, you can deploy FileBit or MetricBit on your Kubernetes cluster to grab all the logs from your Kubernetes pods or all the metrics from Kubernetes itself and send that automatically to Elasticsearch. But in the past few years, we realized that running the entire Elastic stack on Kubernetes, I mean, including Elasticsearch itself, is not that straightforward. So today we have Baby Yoda with us to help understand how you can easily run the Elastic stack on Kubernetes and what that means exactly. So if you try doing this yourself, you may have tried already, it's not that easy, it's not that straightforward. The first thing is there are a certain number of resources you need to manage on your Kubernetes cluster. You need to manage pods, secrets, services, stateful sets, persistent volumes, all those resources that you need to set up for example, your Elasticsearch cluster to run properly on Kubernetes. Once that's done, and once you have your Elasticsearch cluster running, you have to handle what I like to call day two operations, meaning scaling up the cluster, adding more nodes, scaling down the cluster, maybe changing the configuration of that cluster, and then you'd like to do a rolling upgrade. Or maybe you also want to handle version upgrades, upgrading the stack from one version to another. All these operations are not that easy to do in practice. Like it's one thing to have the cluster running for the first time, but it's a different thing to have it in production for several years after that. And then of course, because we talk about Elasticsearch, we talk about stateful workloads. So Elasticsearch is basically a search engine, but also some sort of distributed database that runs on multiple servers. So you need to deal with availability and consistency whenever you do changes on that topology. When you add new nodes, remove some nodes, etc. You want the Elasticsearch cluster to stay available at all times, and you want strong consistency in the data. You also need to deal with volumes. How do you deal with rolling upgrade and make sure the new nodes that you restart reduces the same volume as the previous one? How do you deal with terabytes of data on your cluster? Those are many things that are not so easy to do. Lucky for you, we have a new project called ECK, Elastic Cloud on Kubernetes. You can check it out on GitHub. The code is entirely open. And ECK allows you to deploy the entire Elastic stack, Elasticsearch, Kibana, APM server, enterprise search, and bits on your own Kubernetes cluster. We're compatible with most Kubernetes distributions, including OpenShift and the biggest cloud providers today, AWS, Google, Azure. And the goal of this project is really to tightly integrate with the Kubernetes ecosystem. So when using ECK, you'll use the usual Kubernetes tool in the Kubernetes ecosystem, like kubectl and all the various tooling you can have around that. ECK supports orchestrating Elasticsearch with advanced topologies. I'm talking about hot, warm, cold deployments, where maybe part of your nodes that we call the hot nodes would have a very fast underlying storage, for example, but then you would progressively move that data onto the warm nodes with slower storage, and eventually to the cold nodes, and maybe in the future to frozen nodes, like with very cold and cold and distant storage, like S3, for example. And we want this to support very smooth operations, like scaling up the cluster, scaling down the cluster, rolling upgrades, etc. This should be very easy to do with ECK. So to give you an idea of what it looks like, I'm going to jump straight to a small demo here. So the first thing I'm going to do is deploy ECK itself. That's pretty straightforward. It's just about applying a Kubernetes manifest. So this is a YAML file that I apply on my Kubernetes cluster. So in this example, I'm using a GKE cluster on Google Cloud Platform. So with this single command, you install ECK on your Kubernetes cluster, and we see that it's actually installing a bunch of Kubernetes resources. The first few ones are about installing custom resources for Elasticsearch, Kibana, etc. And the other ones are about all the RBAC access that the ECK operator needs, and installing the operator itself. Then I have a sample YAML file here that describes the Elasticsearch cluster I would like to deploy. So here I have one cluster that I called my cluster. I want this Elasticsearch cluster to have version 7.9.0. And in that cluster, I want two group of nodes, which we call node sets here. The first node set is called master nodes, and it specifies that I want 3 master nodes. So I know those are master nodes because their configuration specifies node.master equals true. And then the other group is a group of data nodes. So here I want 3 nodes, and those are data nodes and not master nodes. So we have dedicated masters on one group and dedicated data nodes in the other group. Then along with Elasticsearch, we are specifying another resource that we call Kibana, which is Kibana, surprise. We call it my Kibana, and sort of the magic here is that we don't specify any complicated configuration so that Kibana can connect automatically to Elasticsearch, which requires a URL, password, a bunch of TLS certificates, etc. Here we just specify a reference to the Elasticsearch resource that we specified right above. So this one called my cluster. And that's it. With this sample YAML manifest, we specified an Elasticsearch cluster of 6 nodes and a single Kibana instance that should be automatically connected to that cluster. So to deploy that on Kubernetes, I'm just going to apply that YAML file using the regular kubectl tool. And what we'll see here in a few seconds in this upper left corner on the screen is that we have several Kubernetes pods that started to appear. We have the 3 data nodes, the 3 master nodes, and we have Kibana itself. So I think we temporarily have 2 instances here, but it's going to get back to 1 instance pretty soon. That's sort of a node Kubernetes back here. So we have those running. And what happened is actually ECK noticing that there's this YAML specification that was uploaded. ECK will do whatever is necessary to make sure this cluster is correctly deployed on Kubernetes. So there are a bunch of pods here. Each pod represents an Elasticsearch instance here. But Kubernetes, ECK also deploys a bunch of other resources. For example, there's a type of resource in Kubernetes that is called a secret. And we have a secret that was created automatically here for the Elastic user, for example. So if I get that secret and look at what we have inside it, we see that we actually have the password of a user called Elastic, which is the default user created automatically by ECK. So I can retrieve that password, which is base 64 in Kubernetes, and I can use that later on to connect to the cluster. Along with that secret, we also have a bunch of services. Services are abstract resources that perform some sort of round robin across multiple pods. And here we have one important service called myCluster HTTP, which is the main service I can use to reach that Elasticsearch cluster. So if locally I do some sort of port forward to that service, I should be able to reach that cluster. So we want to use port 9200, and here I'm going to curl localhost on that port. I'm going to use the password that was specified here, and I'm going to skip certificates validation, because by default, ECK generates a bunch of self-signed certificates for all nodes, so that we use TLS by default. But you can tweak that and provide your own certificates, for example. And if I curl, I can see that I can successfully reach that Elasticsearch cluster in version 7.9.0. And I reached a random node here, like the master node number 2. So a very nice thing that we can do is that we can, for example, add 2 additional data nodes. And that's just about changing the number of data nodes here in that file, applying the file again. And we'll see that 2 additional data nodes popped up here in the list of pods. Again, that's because ECK grabbed all the changes that are necessary, and will do whatever is necessary for that to happen. Something slightly more complicated that is also interesting is, for example, changing the version of Elasticsearch. So that's a version upgrade to 7.9.1. And doing that is pretty straightforward. Again, I change the YAML specification, I apply that YAML file again, then ECK will notice that a rolling upgrade is required for that cluster to use the new version, and it's actually going to do it. So here we see that this node is getting terminated, and pretty soon it's going to be restarted in the newer version of Elasticsearch. So see, this is all about editing that YAML specification with whatever specification you actually want for your cluster. So it could be anything. I could change the configuration here, add a new configuration item for that node, and apply that YAML file again. And that's it. ECK will just deal with it while making sure that in the meantime, you can still access the cluster. There's no downtime. It also ensures that there's no data loss or data unavailability while some changes are getting performed. All right. So Baby Yoda is slightly curious about what we're doing here. It just feels like we're changing a few lines in a YAML file, but he's a bit curious about what actually happens behind the scenes, and that's what we're going to see right now. So what's ECK exactly? ECK was what we call the Kubernetes operator. Operators is a concept in the Kubernetes ecosystem. And basically, we could say that operators are the clients of the Kubernetes API, meaning they communicate with the Kubernetes API. And they also act as controllers in the Kubernetes sense. So controllers in Kubernetes are programs that ensure that the Kubernetes cluster runs correctly. And they're a bit special compared to Kubernetes controllers because they act for a particular custom resource. And that custom resource here is Elasticsearch. So that's a bit abstract. Let's get into some of the details so you better understand what's going on. So the first thing we did here when we installed ECK is deploy a bunch of custom resource definition. So You may know that in Kubernetes API, there are different resource types. We've seen that there are pods, which are like containers. There are secrets, services, and so on. Those are built-in resources. What we can easily do, which is pretty nice, is extend the Kubernetes API with additional custom resources. And here we define our own custom resource, whose name is Elasticsearch. So in this custom resource definition, we specify that the resource kind Elasticsearch has a field named spec. And in that field, there's another field called version, then another one called node sets, which is actually an array, etc. So as a user, you just have to write a custom resource, which is basically this YAML file on the right that respects the schema of the custom resource definition of the Elasticsearch resource. So there's this custom resource thing, which is on the API side. Then there's the operator side of things. So the ECK operator is basically a pod running in the Kubernetes cluster. And that pod registers a few watches on the API server, meaning it's getting notified whenever an interesting change happens on the API server. And this interesting change could be, for example, the user created a new Elasticsearch resource. Automatically, the operator pod gets notified of that and does whatever's necessary for that cluster to be deployed. And that's what we call the reconciliation. The idea is that whenever the operator receives a new notification, it will retrieve the specification of the Elasticsearch cluster. And it's going to make sure it creates or updates any expected Kubernetes resource for that cluster to be created successfully. So for example, if we take this cluster on the left with 3 master nodes and 2 data nodes, once the operator retrieves this YAML file, it needs to ensure that there's going to be 3 pods for the master nodes and 2 pods for the data nodes. But it's also going to do a bit more than that. It's going to create a config map for the Elasticsearch configuration. It's going to generate a bunch of TLS certificates so the nodes can trust each other. Also going to create a secret for the user and the password, and another secret for the Elasticsearch key store if you decide to use it for some of your own configuration secrets. And even more, because in front of that, we want to create a bunch of services. And mostly there's one main service, which is the one you'd use to reach the Elasticsearch cluster using HTTP. So all those boxes on the right are different Kubernetes resources that the operator is managing. If we do the exercise of, for example, removing that config map or removing that pod, the operator is going to make sure it recreates them eventually. So you can break whatever you want. The idea is that the operator will always repair things behind you. It's always running in the background. So again, that's what we call the reconciliation loop. We get the resource, and then we create or update every expected other resource that needs to exist based on the specification we received. But the operator also interacts with the Elasticsearch API. Say you deploy a resource that specifies an Elasticsearch cluster, and maybe later on you update that resource because you don't want 10 nodes anymore, you just want one single node. As you can imagine, if we just remove 9 Elasticsearch nodes all of a sudden, we'll basically be breaking your cluster because there will not be consistency in the master nodes anymore because you move from maybe 3 master nodes to a single master node. So there's no leader anymore. You will probably lose all the data that was on those 9 nodes because you remove them all and there's a single one remaining. That's why the operator needs to interact with Elasticsearch. It will notice that it needs to downscale the cluster from, for example, 9 to 1 nodes and do whatever is necessary so this downscale can be eventually performed in a safe way. So it's going to migrate data away from all the nodes to remove and make sure they are replicated on the nodes to keep first. It's going to also tweak the cluster settings to account, for example, for a single master node instead of 3 master nodes. So those are all operations that you would have to do yourself. I mean, calling the Elasticsearch API before changing the topology that are now getting automated by the operator itself based on the topology changes you specified. One thing we noticed early on in this project is that this very light and minimal YAML specification is super nice to get started. But if you are a Kubernetes power user, you may want to rely on some of the Kubernetes features that you already know. And it would be sort of a shame for you not to be able to provide your own Kubernetes stuff into this Elasticsearch world. So that's why in that specification, we try as much as possible in the operator to provide all the default settings that you need for your cluster to be running in production. But we also want to allow you to override all the settings or to specify your own additional settings if you know Kubernetes very well. And that's why, for example, in this node set here, we have a section called pod templates. You can tweak the labels of that pod. You can give particular affinity settings, saying, for example, that I want all the pods of this node set to be deployed or scheduled on Kubernetes nodes of my end-to-end or production environment, for example. So this is all using the Kubernetes syntax. And I can also override the environment variables of the Elasticsearch container. So here I'm changing the Java, the JVM options. So this is all optional, but basically you can override all the defaults that we set. This is another example about volumes. For each node set, we, by default, create one volume per Elasticsearch pod. And we're using the concept of persistent volume of Kubernetes. Persistent volumes are very nice because their lifecycle is bound to a particular pod. And because each pod is part of a stateful set in each group of pods. So here we have one stateful set for master nodes, one stateful set for data nodes, and each pod in that stateful set has a persistent volume assigned for the entire lifecycle of that stateful set. It's pretty nice because it means if your pod suddenly crashes for whatever reason, like maybe the host died, maybe Elasticsearch ran out of memory, then Kubernetes is going to recreate that pod automatically, and it's going to reattach the exact same persistent volume, meaning as seen from Elasticsearch point of view, this is just equivalent to an Elasticsearch node restarting with the same data. And it's actually how behind the scenes ECK handles the rolling upgrades. If we want to rolling upgrade that cluster, we actually just need to delete pods one by one. At every deletion, a pod is automatically getting recreated and will attach the same volume. So of course, those volumes, they depend a lot on the underlying storage that you have. The default is to deploy volumes of 1 gigabyte, but obviously that's not great for production. You may want volumes of several gigabytes or terabytes. So you can override that here. You would say that you want the Elasticsearch data volume to have 100 gigs of storage, for example. So each pod is now gonna access 100 gigabyte of storage. And then the storage class that you specify here represents the underlying storage mechanism for that volume. And there are many, it just depends on your Kubernetes provider. For example, if you use GKE on GCP, you may want to have a dedicated SSD volume attached to a single pod. If you use AWS, you may want to use EBS volume attached to it, to each pod. And the performance of those volumes, of course, depends a lot on the nature of the volume. You can also use local storage to use the local disk available on each node, etc. So basically, ECK is compatible with all the Kubernetes volume story. And it's sort of up to you to choose the best volumes that fits your Elasticsearch use case. And then in many cases, network attached volumes like the fastest EBS from AWS give you actually decent performance and the advantage of being able to be attached on different pods, even though they may be recreated on different nodes. Whereas local storage volumes, such as local SSDs on your hosts, will likely give you the best performance, but the main drawback is that you cannot move the pod around across different Kubernetes hosts. It has to live where the volume is. So to try to summarize, I think one of the biggest value added of ECK over maybe handling your Kubernetes resources yourself is making sure that your data stays safe and that your cluster stays available, whatever changes you make on the Elasticsearch topology. Additionally, it handles TLS by default. It gives you sort of a simplified configuration for Elasticsearch, handles data migration, rolling upgrades, complex topologies. You can also deal with availability zone awareness by reusing the concept of affinity of Kubernetes to deploy your cluster in 3 different zones, for example. And you can also use cross-cluster search and replication for different clusters, maybe running on the same Kubernetes cluster, or maybe having like one cluster deployed on-prem, another one on Kubernetes, etc. So it's pretty useful. You can give it a try really quickly. I think you've seen before that I was able to deploy this cluster really quickly. You can visit the GitHub page, and we have a link to the quick start documentation. If you have a Kubernetes cluster available, or even if you don't have one, you can install Minikube locally. You'll see that in maybe 5 minutes, you'll have your Elasticsearch cluster running, and it's actually fairly straightforward. That's basically all I wanted to say for today. So a quick overview of what ECK is, how easy it is to use, and what it can do. And I think we have some time for questions now. Before we do that, there's this survey that we try to ask people to fill about our meetups. Dalia, maybe you can try to paste that in the chat. Yeah, oh, good, thanks. So if you can take maybe a few minutes, or a few seconds actually, now or after the meetup to fill this survey, that would be very nice. And then I'm open to answering any of your questions. I'm one of the engineers in the team, so it can be very technical questions or maybe product questions or general questions as you want. So I'm going to look at what we have already in the Q&A pane now. ELK7 can be configured without explicit distinction of master ingest data nodes. Any specific reason? They're created here separately. No particular. So you can. So I think you mean Elasticsearch version 7, but I think you can actually do that on earlier versions of Elasticsearch. So you can, of course, deploy a 15 nodes cluster with no particular split in the master and data nodes. That's going to work fine. For production environments, though, you may want to have, for example, 3 dedicated master nodes whose loads will be dedicated to really handling the cluster state, and separate that from your data nodes, because maybe your data nodes would have a much bigger RAM capacity, much bigger storage, and different CPU constraints. So you don't have to split the node types, but in big production use cases, it usually makes sense to do so. I hope it makes sense. Next question was, how do you deal with persistent volume configuration? Yeah, that was I think the slide that came a little bit after. So that's how you do that. You specify your persistent volume constraints here. So the storage class name, the storage size, etc. It's up to you to pick the best storage class, basically. All right. Are these modular features of ECK equally obtainable on the Elasticstack Community Edition? Yeah, so basically, ECK comes in with 2 different licensing models. The first one is the basic license of ECK, which you can use for free, similar to how you can use the basic license of the stack for free. And then there's the enterprise license, which you would pay for. Most of the features are in the basic license already, actually. But if you want to use licensed features of Elasticsearch, for example, machine learning, then you'd need an enterprise license of ECK. And then we're working on a few more features that will only exist probably in the enterprise license versions. But really already most of the ECK features are in the basic edition, and the big difference is in the features of the stack itself that are not in the basic license, like machine learning. what is recommendation for production scale setup? It's hard to answer because obviously it really depends on your use case, how much data are you going to store, is your use case search heavy, and in which case you want to read data a lot? Is it index heavy, in which case you want to index data a lot? So usually if you ingest logs, for example, your workload would be more ingest heavy. But in general, what we recommend for large deployments, by large, I mean you likely need more than 5 nodes, is a group of dedicated master nodes, at least 3, so that there can be a quorum of 3 nodes with an elected leader, and a group of data nodes. And among those nodes, you likely want to split them in different regions and availability zone. So for example, if there's a failure in the AWS data center where the virtual machines are, you don't want the entire cluster to be impacted. So you want like a third of the data nodes to be impacted, and you know that you have replicas of the data in the other availability zones. That's another aspect. And then I think the last important thing is the hot, warm, cold topology. You can search for it on Google, but basically the idea is that you may want to split your data nodes into several groups with different constraints and different performance requirements. So your hot nodes would be where you query and ingest data a lot. Then progressively, you would maybe move the old data to the warm nodes automatically using ILM policies. Again, this data could be moved to the cold nodes, for example. So I think that's a good example of a large production grade system, right? Dedicated master nodes, data nodes, splitting across multiple availability zones, and maybe splitting the data nodes into hot and warm nodes, for example. Do we have a tutorial page step by step for starters? Yes, let me show it to you. If you look for ECK quick start, let's make that full screen here. You'll quickly end up on this page, probably the first result in Google. And that's really like the entry point of the documentation on the Elastic website. So it's basically going to go through what we just did in the demo, deploy ECK itself. So it's a one-line command, deploy Elasticsearch, like that's this YAML specification that you want to deploy. Then we give a few comments so that you can like get more details on the health of your cluster, see that it's green, get the logs of the nodes. By the way, that's fairly easy. Since we're using Kubernetes, we can just grab the logs of a particular pod like that. And that's how you get the logs for Elasticsearch, and so on. So that's the quick start. And then as you move on to understanding how the system works, you can then go to the more advanced sections. And here we have more details on how to run Elasticsearch on ECK. So how you can configure storage, how you can configure TLS settings, secure settings, custom plugins, etc. So everything is there. I think the documentation is pretty nice. We try to make it easy to digest. So I hope you can find everything in there. Next question was, does the ECK operator handle automatic rotation of the created TLS certificates? Yes, it does. By default, we create certificates that are valid for 1 year. And if I remember correctly, a few days before that date is reached, we regenerate new certificates automatically. We propagate that to the pods automatically. We update the secret that contains these certificates automatically. So basically, you have nothing to do. We handle certificate rotation automatically, which is great. Unless, of course, you decide to provide your own TLS certificate for the main HTTP service, in which case it's like your job to deal with the rotation of that particular certificate of your own. Is the hot, warm, cold role for Elasticsearch node also defined in the startup manifest? It is not, because we try to stay as close as possible to Elasticsearch. There's an example in the documentation here, I think in Elasticsearch section, we have advanced Elasticsearch node scheduling. So we have availability zone, hot warm topologies here. So the way you would likely achieve that is by setting a custom attribute in the configuration of Elasticsearch. You're specifying that this group of nodes is the group of hot nodes. And then you'd say that you want this type of hot nodes to run on Kubernetes instance types with high I/O, very fast storage system. So that's right. For example, this one is, in this example, we have 1 terabyte of local SSD attached to each node. And then we define the warm nodes, setting a different node attribute in the configuration and making sure those pods are scheduled onto different Kubernetes nodes. So here are all the Kubernetes nodes that have the high storage tag. I hope that makes sense. So here, for example, the high storage for the warm nodes is likely configured with 10 terabytes of storage. So yeah, it's up to you to define your own split of group of nodes like that. We're working with the Elasticsearch team so that maybe we make that a little bit easier, and the future, in future versions of Elasticsearch, there may be a different place where you can specify whether your node is hot or warm node, but so far that's the way to do it. Are the nodes trained before we started? What if I run an index without replica? That's a good question. So I think there are 2 different cases to consider for when we're saying we restart or maybe remove a node. The first one would be, imagine you have 3 data nodes like that, and you change the specification so that instead of 3 data nodes, you only want 1 data node. So in practice, what you want to do is remove these 2 pods in the bottom here. What ECK will do is make sure all the data that lives on those Elasticsearch nodes, those 2 to remove, is first moved to the remaining Elasticsearch node. So on this first pod here. And then once that's the case, Elasticsearch will remove the 2 other pods. So even though you may have indices with no replicas, doing a downscale is fine, because then we make sure the data stays safe in the available nodes that will remain after the downscale. Now for rolling upgrades, the situation is a bit different. What we do if we want to do a rolling upgrade of the cluster, which in practice is sort of a restart of every single node one after the other, we just sort of restart the pod itself. We don't care about moving the data first. But once the pod restarts, it restarts with the same volume. So if you have indices with no replicas, what's going to happen is that during the time where the pod is restarted, the data of the single replica is not available anymore. And then once the pod restarts, you can access that index again. So obviously, if you don't want that to happen, the best thing to do is to configure your indices with at least 1 replica, so that while the pod is getting restarted, you can access the replicas on the other side. Technically, we could make it so we would like move data around before doing the rolling upgrades, but it feels a bit overkill. Maybe if you don't have replicas, that's because you don't really care about the availability of your data. So it's better to make the rolling upgrade super fast and not do all these operations, right? And if you don't want that to happen, you probably want replicas, because the chance of losing a pod for whatever reason, because the server crash still exists, right? So if you care about the availability of the index, you probably want replicas. I hope that makes sense. Does the pod template need to be modified when the default CRD has been created by running the default setup command? I'm not sure I understand the question, actually. Just to make sure about the vocabulary here, the CRD is actually the custom resource definition. So it's not like an Elasticsearch specification. It's like the specification of the Elasticsearch specification. So it's a bit meta. What we have here on the left is a CR, custom resource, that respects the CRD definition. So when you install ECK, ECK itself, you don't have any cluster deployed, right? after installing ECK, you need to install this custom resource on the left. So then it's up to you whether you want to modify the pod template or not. If you don't modify the pod template, you'll have sort of a default cluster with default settings. And if you modify it, you can adapt it to whatever you need. I hope that answered the question, because I'm not sure I understood it. If not, please ask another one, maybe more details. Where does ECK store its logs? Nowhere. So ECK really is just a Kubernetes pod. So if we look at the pods on my system, I have a namespace called Elasticsearch here. That's ECK. That's the Elastic Operator pod. So if I want to retrieve the logs of that pod, I can grab them like that in the right namespace. Of course, for production cases, you may want to persist those logs somewhere. And a nice thing to do actually is to deploy ECK, then deploy an Elasticsearch cluster through ECK, and deploy FileBit. We also have support for FileBit. And basically, you'll have FileBit running on every single Kubernetes node, and FileBit will grab the logs of every single container running in Kubernetes. And you can configure it to send those logs automatically to the Elasticsearch cluster you deployed, so that in the end, you can have the logs of ECK itself in an Elasticsearch cluster. So of course, it can be a different Elasticsearch cluster, like you may want to use a target Elasticsearch cluster in the cloud to store all the logs of that Kubernetes system, but you can also use one here. So really, it's like we do nothing special by default for the logs. It's just the logs are just output on the standard output, like any regular container. But then it's fairly straightforward to configure FileBit and Elasticsearch to grab all the logs of Kubernetes and store them in Elasticsearch, which is a bit of inception, right? But it makes sense. That's the right thing to do, I would say. What's the easiest way to move from one storage to another persistent volume? Haha, that's a very good question. I guess you may have experience with ECK a little bit. So let's take this example. Imagine we have those 3 data nodes. We configure the 100 gigs of storage with maybe this GCE persistent disk storage class. Currently, there's a pretty big limitation in Kubernetes, which is that once we created the stateful set that corresponds to that group of nodes, so the data node stateful set on the right here, we cannot modify its volume section because the volume specification of the stateful set is immutable. So if you want to increase the storage size or change the storage class, you cannot do it because the stateful set is immutable, so ECK will reject the update, which is a bummer, kind of. So one way to deal with that is that instead of modifying that stateful set, that not set in practice here, but that translates to a stateful set, you can create a different one. So you create a new one with the new storage size and storage class that you want, and you remove the old one. And in practice, that's just about renaming that one. So if you rename data nodes to data nodes 2, for example, and you change the storage settings here, in practice, it's going to translate to a new stateful set getting in with your new storage requirements, and the old stateful set getting progressively removed by ECK, ECK handling all the data migration step from one stateful set to another. So that's how you can deal with it, basically. It's going to move the data from the old volumes, the old storage, to the new storage. I think we had that explained in the documentation. Now, it's nice that you asked this question because I'm actually working on a pull request so that we can handle storage resize, and it was just merged a few hours ago. Let me find it. That's the name. That's this one, support Elasticsearch volumes expansion. So it's a new feature that's going to land in version 1.3. And the nice thing is now we support, basically, there's a little GIF here, increasing the storage size directly without the trick of renaming the stateful set. And we're going to do an inline resize of the file system within the pods if the storage class supports it. So see here, we increased the storage from 100 gigs to 200 gigs, and it was done inline. Like we didn't need to restart Elasticsearch now the pods, which is pretty nice. So it's going to be there in 1.3. Does ECK work with the Kubernetes topology spread feature to spread nodes evenly across availability zones? Yes, I think it's a feature of Kubernetes 1.18, if I remember correctly. So if you remember this example where we use affinity settings here, you can use the topology spread feature directly in that pod template spec. And that's just going to work as you would expect with Kubernetes. So yes, it's actually pretty good because before that, to deploy things in multiple zones, you would have to define multiple group of nodes with one zone per group. But now you can define a single group of nodes for the data nodes and say that you want to spread those pods across multiple zones. So you don't need to specify this multiple group zone. I was wondering if ECK would automatically monitor the health of nodes and take remediation if necessary. If so, how is it implemented? The operator of your Kubernetes probes. So that's a good question. So there are two mechanisms in place for that. The first one is that actually three different mechanisms. ECK monitors all the pods of the Elasticsearch cluster in Kubernetes. If anything changes in those pods, for example, here, if I delete this data node, don't do it, but you can do it, it works. I delete that node, it's a pod. What's going to happen is that the status of that pod changes. It goes to terminating, and then it's going to be removed. Every time there's a change in the status of a pod, ECK gets notified. So it can do whatever is necessary to sort of fix that. So here ECK will notice that the pod is getting terminated. In maybe 20 seconds, it's going to notice that a pod was just removed and is missing, so it can recreate that pod automatically and everything that's required for that pod. You also see that we have like a sort of a ready flag here. So this pod is not ready anymore. That's because with each pod, we deploy a readiness probe. The readiness probe is basically checking that the Elasticsearch API responds for that particular node. So that's deployed within the pod. And then the third mechanism is that within the operator itself, we regularly pull the Elasticsearch API to see if the cluster is healthy. So basically, we call this API here, cat health API. And this is, oh yeah, I need to restart port forwarding because it was probably connected to an old port. This is telling us that the cluster is currently yellow. It's actually yellow because one node is still starting here, see, 1.1. So now this new node what we created, so it's likely that in a few seconds, the cluster will be green again because the replica is alive. Yes, here it is. So we do monitor this status regularly. We pull this endpoint from within the operator, and if there's any change in the status, like we notice it's going from green to yellow, we'll try to repair things. But in most cases, we only need to repair stuff when there's something happening to a pod. So we actually do detect that from the pod resource itself directly. Hope that makes sense. We're going into the details, but that's nice. In case of local disks, does ECK make all the magic for you, or is some additional configuration required? That's a super good question. I wrote actually a documentation for that recently. If you go there, maybe it's there in the 1.2 documentation already. There's a section about storage recommendation. It's pretty useful to read because it talks about storage in general, and specifically it focuses on the difference between network attached and local persistent volumes. So in your case, if you want to use local persistent volumes, the thing is, you need to have a local volume provisioner available on your Kubernetes cluster. So one thing you can do is like manually create this sort of persistent volume resource yourself. So here I'm saying, for example, I have 500 gigs of storage available on that particular directory and on the particular node. So you create that YAML file. And if you specify that you want an Elasticsearch cluster using that storage class, then ECK will automatically match your Elasticsearch pods with the existing volume resources that you create. Maybe you don't want to go into the pain of creating those yourself. So that's why there are several provisioners available. A good example is this static provisioner here. Basically, it's a program that you deploy. It automatically discovers all the disks that exist on your different nodes and create the volume resource for that automatically. And then I think a pretty good third example is TopoLVM. TopoLVM is a dynamic provisioner. As compared to the static provisioner, which would create persistent volume of the right size depending on the disks you have automatically, and then you can use those volumes. TopoLVM will dynamically provision a volume as you need it. So like maybe you want 10 gigs of storage, TopoLVM notices there's a request for 10 gigs of storage. It's going to create an LVM volume on one host with exactly 10 gigs of storage and provision that on demand. It's a bit more complicated, but it's very powerful. So the short answer to your question is yes, you probably need to look into one of those three solutions to make sure what's going to be your strategy for local volume. There's nothing that comes bundled with ECK for local volumes, but we rely on whatever's possible with Kubernetes local volumes. Does ECK work with the Kubernetes service topology feature? For example, to prefer network traffic to stay within the same availability zone, to not pay for cross availability zone traffic? That's a good question, actually. I think there's nothing special to ECK here in the sense that whatever you can configure in Elasticsearch to define the different regions of each group of nodes can be configured with ECK. So it's up to you basically to configure Elasticsearch the right way according to your Kubernetes topology constraints so that it fits your needs. And then an important thing is that remember there's this service that we create, that ECK creates automatically. So this one, for example, can direct requests to any node in the cluster. You can easily create your own service on top of that. You can, like, in the service specification, restrict that you want packets to be routed to a particular set of pods. And so if you have a label set for a particular availability zone, you could make sure that the service only directs requests to pods of that particular availability zone. So that's one way. But then, of course, I mean, if you have replicas on multiple zones to deal with zone failures, I don't think there's anything you can do around the need for Elasticsearch to replicate data from one node in one zone to maybe another node in another zone. If you don't want that to happen, you can either have no replicas, which is probably bad, either have all the replicas in the same zone, which is also a bit dangerous, right? I hope that answered the question. Do you have any plans to implement a Kubernetes autoscaler to autoscale around disk usage? Yes, that's a very good question also. It's a work in progress, pretty much work in progress. We're still in the design phase. It's not there yet, but by the way, there's an event called Elasticon Global next week. Elasticon is our big Elastic event with a lot of presentations. And it's free this time. You can register for free on the Elastic website. And we have a whole session dedicated to autoscaling. Basically, what we discovered is that autoscaling in Kubernetes itself is nice, mostly for stateless services. For stateful workloads like Elasticsearch, it doesn't work that well. It's a bit more complicated than what Kubernetes offers. What we're actually working on is implementing some autoscaling features in Elasticsearch itself. So Elasticsearch can give us hints about what should be autoscale. Data nodes, master nodes, more RAM, more CPU, more storage. And then ECK would react on that signal and automatically scale the cluster depending on that. So we're working on it, yes. Not there yet, but pretty soon, I hope. Is the recording shared? I guess you mean, oh yeah, so I think this session is recorded, Dalia, if I remember correctly, it's gonna be on YouTube.
Exactly, the YouTube link is in the chat, so it's gonna be uploaded there in a few days.
Okay, cool. That's nice. So I can say things like the YouTubers say, like, please add a thumbs up, subscribe to my channel. What about custom plugins? A good question as well. We have this, I think, covered in the documentation. So the idea basically is that when you customize the pod template, you can add your own init containers there. And you can add an init container that is going to install any plugin you want before Elasticsearch runs. So we make sure of all the underlying tricks with the volume mounts so that the plugin is preserved between the init container and the actual Elasticsearch container. But basically, that's the way to go. So if you want to install your own plugin, you would specify a URL to that plugin here. And basically, that's it. Yeah. What metrics are exposed by default? Oh, by the way, we're close to the end of the hour. Can we go on for like 5 minutes, or are we strict on timing, Dalia?
Finish the questions, no worries.
Yeah, cool. So what metrics are exposed by default by all cluster nodes? In which format? Is Prometheus format supported? I think it's not. So it's an interesting question. Elasticsearch by default exposes almost everything. If you call that API, for example, if I remember correctly, maybe it's not that. I don't remember. Let me find it again. Cat. I think I can do cat nodes maybe. I don't remember. I think it's something about nodes title, maybe just nodes like that. Yeah, so if you do that, you have a lot of details around each individual node. So you see settings about the thread pool. If you change a few things in the query parameter, you can expose the RAM usage, CPU usage, the JVM heap size usage, the garbage collector information, and so on. So it's all in the Elasticsearch API. And so far, those metrics are only exposed in the Elasticsearch format. So that's the really in this JSON Elasticsearch custom API. But what you can do, which is super interesting, is deploy bits alongside Elasticsearch on your cluster. So we have some examples here for running bits. And in this configuration examples section, we have something about Elasticsearch and Kibana stack monitoring. So if you deploy this manifest, it's going to deploy bits on your Kubernetes cluster, and bits will automatically grab those metrics I just showed you from the Elasticsearch clusters that are available and store those metrics in another Elasticsearch cluster that you dedicate to metrics, so that you can then visualize those metrics from Kibana, for example. I think we have a blog post that covers that actually, that was, I think, released yesterday or something. Yes, Elastic Stack Monitoring with Elastic Cloud on Kubernetes. So it gives you an example. You have a production system, you have a monitoring system, and you want to send the metrics of that production system to your monitoring system, right? In the end, in Kibana, you would see things like that. So you'd have the health of each individual Elasticsearch, Kibana, etc. cluster, and you can drill down in more specific metrics, CPU, RAM, number of indices, shards, garbage collector, and so on. What is responsible for time counting in tmux or CSDSH prompts? I think you mean that one here. That's actually a watch command that I'm running here. So that watch command is giving me the time here. I used to have a time reported by tmux, but I noticed that it's refreshing the terminal too often, and it's actually killing my battery. So I stopped doing that. No watch seconds counting. What do you mean? Do you mean that one? Or do you mean like this, the H here? That's a Kubernetes features. Or maybe you mean maybe you mean this, which is the time for which I run the command. I think that's the ZSH plugin that does that. Yeah, yeah. I'm using the. I'm using this nice prompt, which is called pure prompt. I think it comes bundled with that. It's pretty nice. Yeah. I think that was the last question. Thank you everyone for listening.
Thanks for answering all of the questions. And thanks guys for asking such amazing questions. The recording will be up in a few days on our channel, and you have the link in the chat here where you can see it. Cool, thank you. Thanks everyone. Thanks, Sebastien.
Thank you. So usually that's the time where I would ask for the best pub to go to and have beers next. But
yeah, hopefully.
Everybody's welcome to my house if you want to share a beer.
Cool. Thanks guys, have an amazing weekend.